Plumbing waste pipework needs to be ventilated to relieve positive and negative pressures created by the flow of liquids through the pipes. McAlpine's solution to plumbing ventilation is the air admittance valve, or AAV. These are pressure-sensitive one-way mechanical vents. They eliminate the requirements to terminate the vent stack above the roof, meaning the pipe can be terminated inside the building. McAlpine have been at the forefront of this development for almost 50 years. One of the historical development reasons of the AAV was to remove the blockage risk created in the Scandinavian countries where large snowfalls covered the vent pipe. The need for ventilation can be illustrated with a simple test. Here, a WC and sink trap are connected to a vertical soil stack. The stack is open to atmosphere, simulating a through-roof vent. When a WC or other appliance discharges, a volume of wastewater enters the stack. A similar volume of air is displaced to accommodate this discharge. This displaced air will create a pressure difference, in this case, negative. Air is sucked in, normally via the path of least resistance, through the vent to equalise the pressure. This test shows what would happen if there was no ventilation. The WC is discharged and air is displaced, creating negative pressure. Air must be drawn from somewhere. The path of least resistance is the sink trap. Air is pulled in through the trap. This also sucks out water, which drains the seal. Where a trap has lost the water seal, this conduit can allow sewer gases to enter the building. Sewer gases can be noxious, toxic, and explosive. They normally contain methane and may potentially contain viral, bacterial, and fungal pathogens in addition to other organisms. Ventilation also allows sewer gases to escape the plumbing system. An AAV will not allow sewer gas to escape. Under positive pressure or neutral pressures, it remains airtight, keeping sewer gas within the system. It is much easier to move air than water, so during negative pressure, it allows air to be drawn in. This ensures water seals are maintained. When the pressures equalise, the valve closes again. The AAV houses a moving diaphragm. The diaphragm stays closed under neutral and positive pressure. During a discharge, the negative pressure within the piping system lifts the diaphragm to allow air into the system. The internal and external pressures then equalise and the diaphragm closes by gravity. The diaphragm will remain closed during positive and neutral pressure, which will keep foul air within the system. An AAV can also act as an advanced warning system against blockages in the building sewer. When the WC is discharged, no air is displaced due to the blockage. This creates positive pressure within the system. The AAV remains closed during positive pressure, so air escapes through the trap. Water and debris are forced up into the sink basin. Water will drain back into the trap, sealing it, and debris left in the basin would highlight the blockage prior to any flooding. McAlpine AAVs are subject to rigorous testing to ensure they comply with European standards. The McAlpine 110mm valve has a flow rate of 47 litres per second at a negative pressure of 250 pascals. This high flow rate is well above industry norms. AAVs are also tested to ensure they remain airtight at low pressures. For systems up to and including 4 dwellings that are 1, 2 or 3 stories in height, additional drain venting is not required. A single McAlpine AAV has the capacity to maintain pressure in an intermittent running system, such as a house or office, a frequently running system, such as a hospital, school or hotel, a continuously running system, such as a public toilet, and in special circumstances, such as a laboratory. The use of AAVs is approved under Building Regulations Approved Document H3 in BS EN 12056, though only AAVs manufactured to BS EN 12380 are suitable for use in sanitary pipework systems. The airflow rate of any AAV needs to be taken into consideration when the system is designed or being modified. It is important when dealing with multi-storey buildings that the AAVs are sized correctly and in accordance with BS EN 12056, which states that the valve has to be 8 times the peak airflow rate of the soil stack. Where an AAV-equipped drain serves more than 4 stories, there are specific rules about how the drain should be vented. McAlpine understand that it is not always possible to access the main stack and fit an AAV. A resealing trap fitted to an appliance, such as a sink basin, will protect seal integrity. Resealing traps create an easy path of negative pressure resistance. A reduced amount of water is displaced within a baffled sump to create an airway for air to be drawn into the system. A silent trap fitted to an appliance, such as a sink basin, will protect seal integrity and remove unpleasant glugging sounds. Silent traps incorporate the small-scale use of an AAV principle utilising a small valve within the trap. Under negative pressure, the valve opens prior to the water seal being displaced.